Alright, so my Tesla coil primary driver just blew up again, and I decided that it might be interesting trying to sort of prise apart the IGBT that died, just to see if maybe something is visible inside it. Now, if I zoom into it, you can see that the life has oozed out of it. It's a bit, I don't know, the zoom of the camera isn't perfect, but I think it's still visible that there's something quite wrong in this area here, because I don't think that's supposed to be on there usually. So let's zoom out again. Now, honestly, I've got no idea how long this is gonna take, so if it takes too long, I'll just skip it in edit. So I might just be talking to myself right now, but we'll see. So first of all, I'm just gonna be bending out of the way. Let me also just move that in frame again. I'm gonna just be bending out of the way the actual connection tabs. These things, they're just normal M4 washers, so if you're so inclined, you can actually still use them if you're like really desperate. I probably will. I am desperate. Now, you can see that these washers aren't really the silvery color that they should be usually. I think, if I just zoom in once again. Yeah, they're not really alright. They're very, very dirty. And it seems... There you go. The zooming I still have to practice a bit. Yeah, it seems that all of the stuff basically just came out of this hole here. If you just look at it, this is just... yeah. That's still pretty shiny. That is the gate. This thing here is the one emitter connection. That is... yeah. So this here is the gate, that's still shiny. This thing here, collector, still kind of shiny. There's some dirt in it, but I think that's just from like some shit that got that fell out of the washer while I was putting the screw in. Same thing here, and then there's this. Yeah, it died. So it probably just blew up right underneath here. Now, I don't know where the die is situated, like, in the package. But I'm suspecting that it's gonna be around this area here. Because these two ones are the power connections. This is the emitter that I connected to the, to the bridge. And that is the collector. This is the Kelvin emitter. Technically, they're both usable as Kelvin emitters, but I use this one, and that is the gate. So, this is the one that would have had the current go through it, not this one. So I suspect that the die is somewhere situated around here. But hopefully we'll see. I've got no idea how far it's gonna get, so... If it doesn't work, then you won't even see the video. So, now that you're seeing it, you can be sure that it's gonna work. Now, I actually don't know how to continue on from this. You can really see, though, that these things are very, very dirty. Let's just see how far we can crack our way into this here. I hope I'm not gonna have to use like saws or some shit, because that I can't do here. Well, I could, but I don't want to, because I'm just gonna mess up my table. Which I am anyway, I think. This is just gonna spray everywhere. This is very brittle plastic. Another thing that this allows me to do is to just take revenge on the thing that killed my Tesla coil. I probably should put on some gloves. This is getting very dirty. Not that this is like actually anything toxic. At least I don't think. I mean, it's just plastic. Some sort of a resin. But I just don't want my hands to be so fucking greasy or whatever. It's not really grease, it's just soot. The magic blue smoke has just gotten all over my hands. Ah, that looks promising. I can see something shiny in there. That'd be the dye. I see holes in the dye, so I guess that's the problem. Let's see, can I maybe remove this kind of carefully here with a screwdriver, maybe? I haven't seen any bond wires yet, so they might have just disappeared. you see that? Sorry. Yeah, you can see that I'm an absolute professional YouTuber and certainly know what I'm doing here. So, yeah. You can see where the bond wires were attached. Sort of, if I just zoom in again. Like there, these things here and these things here. It's funny that this thing is supposed to be, one is supposed to be the Kelvin emitter and one is supposed to be like the power emitter. Again, the datasheet says you can use either, but it's like literally, okay, we just connected it there and connected it there. Use whatever you want to, it's not gonna make a difference because it's just the same thing anyway. I mean, I suppose resistance in this thing here is gonna maybe make it a bit better to use this one rather than the other, but it's not really a Kelvin emitter that connects to just one part of the die. Now I can also see, keep going out of frame. I just move the camera down a little bit so that it's pointing to where I would actually hold it naturally. This is one part of the die and this is the other. Now I don't know if this is just substrate. It almost looks like it. This doesn't really, if I have a look at it. Yes, this just looks like a coated copper substrate, with that being one die and that the other. Now, IGBTs don't naturally have a body diode like MOSFETs do, so they add one, because it's a very, very, you know, I wouldn't say it's always needed, but it's needed pretty much 99% of the time when you're using these things here, just so that if you have current wanting to flow in reverse, it can go through the diode, because again, it can't go backwards through the transistor, because this is just a BJT, well, it's just a BJT technically, being driven by another MOSFET. It's a bit more complicated than that, but it's safe to assume that it's just not going to have any current flowing in reverse through it, so that's why they add the diode here. In my case, I don't actually know which actually took the sort of damage. I kind of suspect that it might be the diode, because it would have actually had quite a bit of current flowing through it, but I don't know. So there we go, just continue taking that apart. So you can see that the collector here, this is the collector, that is actually connected straight through to the substrate. It'd be interesting to see sort of how they actually insulated like the substrate and the, I guess, substrate, like the base. Because this goes to the heatsink and it's isolated from here. It's not like TO247 ones, where this is connected to, I don't know, the center pin, which is collector or whatever, or drain. Because these things, you know, it's hard to actually insulate these things while still keeping good thermal contact, and these things are designed for such high power applications that the little bit of thermal resistance that would come in from like an insulating pad or whatever wouldn't really do any good, so they just insulate these things here, and I think this is rated for 2.5 kV isolation between the actual the actual power path and the base. But I don't know, they obviously have to isolate it somehow, so I've got no idea how they did that. But I'll obviously be able to see that once I pull this out. So, yeah, if I just probe this really quickly. I'm not gonna put the multimeter in shot, but you can hear it, I think. These two things are not connected. That's sort of the idea of it. Now, yeah, I'm gonna just try to actually sort of scrape off the existing plastic here if I can. You can actually see that this diode, I don't know, it just doesn't look right. It just looks like it's flooded with solder or something, and I really don't think that that would be the case. It also looks a bit glittery, so I think this is actually the silicon surface being broken up by me just ripping it off. Basically just ripping off the plastic. And I just cut that thing off. That's one of my shitty pliers for that, if I could find it. Yeah, I don't know, I've just got my pliers in like a box and it's very messy. So there you go. It's gonna be kind of hard to continue on from here because I don't really have a way to like hold on to it. I don't really want to just crunch it because it's just gonna go everywhere then. Yeah, I think I ripped apart the diode die. That just doesn't look right. Maybe I can pull out the entire substrate here. I'm gonna zoom out a little bit again so you can see the carnage. Yeah, it's coming. Gonna do it upside down so it doesn't like spray all over the workbench. It's starting to come out, but it's not quite happy about it. I feel like I'm gonna get stabbed with a screwdriver here in a second. Yeah, it's just bending. Oh, it's actually soldered down at the back. Okay. Interesting. Not sure if you're gonna be able to see that. Yeah, that's zooming though. That's the substrate from the other side. I just tried to pull it up and do I have a flashlight around here? That preparedness though, wow. Just in there, yeah, the quality is really bad zoomed in that much. There's like solder in between this part here and the actual substrate. I keep saying substrate, but I don't know if this is actually substrate or this is substrate or this is base or whatever, so I think you know what I'm talking about. Now, one thing that I'd just like to point out though, if you just look at this, you can see that clearly one of these things isn't happy. And something bad has happened to it. Now, this or that. This here I'm pretty sure is the diode, because the gate was on this position here. I'm gonna just put it down on the table so it doesn't keep shaking around that much. The gate connection was on this side here, emitters were here, and this here was the collector. So I believe that they wouldn't have the gate here and the IGBT die over here and then have to run bond wires from, I don't know, here to there. Guess that'd just be fucking wasteful. So yeah, I think this is the diode, and the diode is fine, and the IGBT just, you know, spat its guts everywhere. Yeah, I don't know, the camera just doesn't really seem to be happy about focusing on something up this close. You have to remember that this is about, I don't know, 1.5 meters away, and this thing is, you know, I don't know, 2 centimeters by 3 centimeters or whatever, so it is still quite an impressive zoom. I mean, if I just zoom out all the way, you can see it's quite impressive. But yeah, I hope nobody's gonna get seasick from this. Would be kind of funny though. Right, now the question that remains is, how am I gonna manage to get away with this plastic here? How about carefully try to hammer away that. I don't really have a small hammer around here though, so yes, that looks to have worked out quite well. And here you can actually see the insulating layer, so it's like maybe I can scrape it off a bit more. Now, technically I did finish the course at uni where we were talking about such things, but the prof in the end was like, yeah, you know, it'd be nice if you'd have like BJTs that wouldn't require any active drive current, and you know, we just finished MOSFETs, but we don't have any time to speak about those, so we're not gonna speak about them. So it's like, I literally don't know anything about these things other than, hey, there's a gate, there's a collector, and there's an emitter. It's like similar to a BJT and a MOSFET. That's all I know, so. But yeah, you can actually kind of see sort of the insulating layer, that this here on the top, I can just point with the tweezers because they're a bit smaller. This here on the top is like the thing where the actual dies are on, and that is the collector. I'm kind of wondering if this is maybe a bit dark. Can just adjust the light a bit. Then there is some sort of an insulating layer in between. This might well just be some silicon. just non-doped, and you know, just so that the charge carrier density is low enough to make it an insulator. Well, yeah, that. And then on the bottom there's just another copper piece, which just, I believe this is the same as this here, just that there's still some plastic in the middle here. But, yeah, it's interesting. This is supposed to be able to insulate 2.5 kV, so, yeah. I kind of know, I don't know, I'd be interested to know which kind of material this is. I mean, it probably is silicon, because that's sort of the thing that I think of, but maybe some fancy ceramic thing that just looks like metallic. I don't know. It's hard to say. Gonna just try to tear some more resin off of here. Keep saying resin. I don't think it's an actual resin. It's just injection molded plastic, really. There you go. The inner secrets are revealed. There you go. Yeah, now you can see it like really well. Actually, hold on a second, I'll show you in a minute. Just gonna want to see what's going on myself first. Yeah, okay, no. I was just thinking that there was maybe like another layer in between this and that, but I think that this is just sort of some burr that was on here. Yeah, kind of interesting though, but yeah, again, you can just see that this thing has just been completely blown to bits. There are literally fucking craters in the thing. Yeah. Just take off the other side here. The hammer seems to have done a fairly decent job. Yeah. It actually sort of cracks it off right here, which is pretty nice. I don't know, I'm also just seeing that the camera is sort of overexposing this area here. That looks a bit weird on the preview. That might just be the monitor though, I don't know. Let's see, can I get this thing here off as well? Yes. I'm also kind of trying not to make holes into my ESD mat, but yeah, so far there are no holes in it at least. So there you go. Yeah, it's just pretty much the bare construction, only no connections or anything. I don't know, I kind of want to rip this off, but I kind of don't. Because then it just... Because it's soldered, it's just gonna mess it up. I suppose I could try desoldering it. Would that work? I don't know. I don't know if it's worth it. Because this is a fairly decent thermal mass, and if I heated that up now with my hot air station, it'd be quite a while. And I don't really have all that much time right now, so... Yeah, this is probably some low temperature solder down here though. Just the maybe the same stuff they use in CPUs. But I'm just currently trying to see. I had a frame again, aren't I? Yeah, sorry. I'm currently just trying to sort of figure out where the bond wire is attached to this thing here. Gonna just put it down and zoom in again. Oh yeah, there's some nice dents in my mat. Fuck. Oh well. The carnage must continue. So it seems to me that first of all, this is completely unfocused. I'm actually thinking about getting my microscope out. Yeah, I'm gonna just get out my microscope. Just hold on a sec. Alright, it's a bit zoomed in, but the microscope is here. So these things here are the scratches that I made into this that I made in the surface from hammering off the plastic on the side. This here is the diode. I don't know, it just looks a bit weird. You can see sort of there. You can see the sort of pitting on the surface and some leftover plastic. I don't know, it just looks wrong, so I'm suspecting that somewhere in the pieces that I broke out... Yes. I just found it. There's the rest of the diode. Yeah, maybe I should have been a bit more careful. How thick is it there? It's actually quite a bit of, you know, silicon that I ripped out. Surprising. Okay, so you can also see the bond wires pop up and there. So it's safe to assume that this was the diode and that's the only bond wires going to it. And I just killed it by, you know, brute forcing the thing out of it. Right. Anyway, back to this. Get it in focus. So this is the leftovers of the diode. This, I'm just gonna say substrate, is copper, plated probably with nickel. If you see, I don't know, can you see that? It starts to get it starts to get sort of copper colored where I scraped the coating off. And yeah, this is the moon. I don't know, you can see sort of the meteor impact craters here, and I think this is where Apollo 11, yeah. Honestly, it just looks so horrible. There are like literally craters in the surface here. Yeah, I don't know, like, there's just so much stuff on here. I don't know what this is, this here. If it's like something, if there was like this as the base and then some other layer on the top and this is just the remains of that. But it's terrible. So positioning wise, again, this base here is the collector. This probably would have been the attachment points of the emitter bond wires. They would have gone over here. This is where the emitter was. Let's see if I can find that bar. Here it is. That would have been in here sort of like so. It's a bit bent, so it's out of focus, but you can see that the bond wires would have gone sort of from over here to over there. And they just vaporized. You can also see a lot of like vaporized metal deposits on here. It just looks terrible. And yeah, then there's this sort of stuff. It almost looks like solder and is also quite soft, but I don't know what it, like, why there would be solder on here. Like on the top of the thing. Oh yeah, and the gate would have been on this side here. So I suppose the gate bond wires would have gone in somewhere around here, but I don't know. I just don't see any attachment points for those. Maybe they were on this. It could also be, of course, since I also ripped off the top layer of the diode, that this is sort of the remains of the top, oops, sorry, of the top layer, and the rest of the top layer is somewhere in the mess that is around here that I can't find right now. Just trying to puzzle together the remains of the diode and whatever we had. So here's... I did find the remains of the gate, but I don't actually see any remains of the actual, like, transistor on them. I would show you, but it's literally just black plastic, so it's not really worth it. So what could, of course, also just be is that since this was quite the violent fault, I would say, it just disappeared and, you know, the magic smoke escaped, and coincidentally the magic smoke was sort of the top layer of this thing. I don't know. You can also see this green stuff here, which is probably just the top oxide layer. For insulation. I really don't know. So if you know what it is, sort of what exactly these individual layers here are, I'm gonna just sort of do a side shot. This really just looks like the fucking moon. Yeah, again, so if you know sort of if this is actually the top layer or if it's just vaporized or whatever happened to the gate connections, then please comment below. I'd be very interested in knowing. But yeah, this is a violent fault. I was initially suspecting that maybe the diode died. Just a quick sort of summary of what my current issues with my Tesla coil primary are. The transistors keep dying, or the gate drivers. The gate drivers, I believe I might have fixed, because there was some issue with the logic level. But then I suspected that because I'm switching these things off quite early on in the current sine wave, making the current that obviously still flows, because it's not just going to stop, it's an inductor, flow through the diode of the IGBT that is to be turned on next. And I suspected that maybe the diode was overloaded, but I think it's obvious, you know, which one of these actually was overloaded and died. Yeah. Still fascinated at just the damage that took place here. I mean, seriously. If you took a picture of that and send it to me saying like, yeah, this is some, I don't know, explosion crater, meteorite impact, something, I'd believe you. I mean, this is so messed up. I mean, look at how deep these things are. Yeah, I guess it's not really a surprise then that there was a short between emitter and collector when I was checking these things out after the explosion. Yeah, now of course the actual size of this is tiny if I just zoom out again. This is my pinky, it's like a lot larger, but it's still very powerful. And this would have had a lot of energy dumped into it. The other one of the transistors, this is just, this was part of a full bridge, and only one of the legs died, so half of the transistors, 2 out of 4. This is the other one, there's like no visible damage to the outside at all. Like, the only thing that you can see is that there's... Okay, maybe I should not use the microscope for that. Just move that to the side. And switch to the camera. So this is the one that we just had a look at, and this is the other one. Yeah, you can see that even if you compare it to the way that, you know, these parts looked before I tore them apart, there is nothing, there's no crack in it, there's nothing, but the gate and emitter are still shorted. Now, do we want to have a look inside this one here? I think we want to. Now, honestly, it could be that the video is just too long, so if you just see a jump cut and, you know, past this transistor being taken apart, then there was nothing interesting in here. And I just skipped it, and, you know, you'd see, hey, thanks for watching, blah, 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 and then there's just this thing in ruins, but, you know. Alright. Oh, I see damage. I see damage. Yeah, I'm gonna just switch to the microscope again for a second for this. So... the audio quality is gonna be different because now I'm not sitting in front of my microphone anymore. Because the microscope is just on the other side of the table. So, let's have a look at that. So... that is the same part that we had before, and there's again this sort of weird looking, I don't even know what this is on here, this, and this is the bond wire. Now this is not the bond wire from the gate, I don't think, because if you look at it from the side, you can see that it goes sort of towards the emitter, this thing here, this guy. And not towards the thing that I just ripped out, which would have been the gate. So, let's continue the carnage. So I'm gonna try not to rip the collector out too soon, because that sort of bent the entire substrate base, whatever. So maybe I can even manage to crack off this here, and then from there break this thing here out without ripping the bond. Okay. Yeah. Scratch that. Bond wires died. The diode died again as well. I believe that they make the bonding so that they stick this thing down, then they bond the things over from here to there, and from here to there, and then they cast this thing in the sort of plastic here. That's kind of the only explanation I have. And you can see that there's some shiny metal in here again. This is the diode. So yeah, this is sort of, well, the remains of the diode. It's not really a diode anymore. Well, actually, it'd be kind of... I don't know, where would it break? Would it maybe break along the separation between the two doping types? I don't know. Has it still got continuity? If it's just one doping region, it should. But it doesn't. I doubt it, to be honest. I just don't think anything would be connected. Okay, actually... Yes. This thing, though not being a diode anymore, has got 0.66 volts drop in one direction and 0.4 in the other. Interesting. I wonder why it's so much. It must just be that, I don't know, the charge carrier density is so low. But if it's a one, yeah, if it's P doped or N doped, I honestly, I don't know. Doesn't matter. We're gonna just see if maybe we can still have it work. I mean, okay, no, I was just wondering if I could measure from here to here, but this is just the same thing, just that I did over here, just the other way around. I mean, I suppose maybe. Yeah, I could just do that. So that's just a short, as you can see. Just sort of trying to see if it maybe changes depending on where you are. Which it on where you measure, not where you are. Yeah, I mean, it's still got some sort of diode characteristics, but not really. I mean, who would expect it to still work? It's literally been ripped in half. Still interesting that it kind of acts like a diode, though. That might just be resistance, though, I don't know. I'd have to measure it a bit more current to see that. Right, so this thing here doesn't want to come out. There you go. Yeah, this thing just rips apart the diode as it connects. Oh, actually, I just see something else. I believe. Do I? No. Okay, no, I just saw something shiny over here, and I thought it had ripped off a part of this die, but I think there was just, you know, leftovers of the diode, you know, sort of falling over to the other side here. Let's see. Can we manage to pull this here out? No. I'm trying to do the sort of the minimal damage possible right now. But it is kind of hard to do, of course. Because this thing is like a solid piece of metal. There we go. So, yeah, you can see a lot more of the structure of the IGBT die. I'm gonna switch over to the microscope in a second. But there was some damage here again, but it's a lot less than it was in the other one. I'm actually gonna see if there's still continuity. There you go. Now you can see what I'm seeing. I'm really not used to talking for such a long time and continuously. So, yeah, this is just all dead short across here. Everything. Now the question is, should it be or shouldn't it be? I've got no idea of sort of the actual die layout, so I can't make an educated guess, unfortunately. But I suspect that, yeah, it's not wanted that this is continuous. So probably what happened is that this thing here just blew up or whatever. I'm gonna switch to the microscope now. Carefully push everything out of the way here. There you go. And switch. There we are. So this is what's left, and I think it's kind of obvious to see sort of where that short circuit has occurred. Yeah, this looks very, very messed up again. But luckily the damage isn't that much, and you can still see the connections for what I believe would be the gate. Because you got many connections in the center here, sort of 4 and 4. And then one on the side here. I believe this one here would then be the gate. And let's see. These 4 things here would go over to this non-existent thing here, which is the bar for the emitters. And this would be one side and this would be the other. Yeah, I think this is thermal damage though. It just looks charred. So let's see. I'd really like to know the die layout right now. I'm gonna just look it up now. This is really, really interesting. So, so that kind of explains this structure here, I suppose. I'm gonna actually just size this thing here up a little bit. Where are we? There you go. I hope you can actually see what's going on here. That's actually kind of nice, because this here is the copper layer 1, where the actual die is on, which is this guy here, obviously. So that would be this thing here and that thing there. Then here is the insulator, which I suspected to be undoped silicon. But it obviously isn't, it's just aluminium oxide. You know, a ceramic, as I kind of was wondering about. It looks sort of metallic. Anyway, it's aluminium oxide, as you can see here. Then there's another copper layer on the bottom. Here. And then this thing here shows sort of another layer of solder and the module base plate. But that's for sort of the larger modules, so I believe sort of, you know, the ones that got a full bridge in just a single package. So yeah, I believe that this is like you know, this is something else. This is, you know, it's more advanced than the one that I have, let's just say. And you know, here the actual diode and this thing here, I think this is supposed to be the diode, are on 2 different pieces of copper, and here they are on the same piece. This is not isolated from each other. Alright, so all that's left now is to clean this mess up. I'm very happy I've got a vacuum cleaner down here. And yeah, fix the coil up, I suppose. Now, if you found this video interesting and you sort of maybe even interested in some more of my rather random projects, then I've got a website. I'd be happy if you checked that out. And of course you can subscribe to the channel as well, even though my upload schedule is very, very, very slow. I mean, I made the last video like a year ago and that was on some random water rocket thing. But you know, I might post some more videos about this stuff, and if the Tesla coil actually worked, I'll of course make sure to post some videos of that playing some music. And I guess see you next time. And now let's just clean that shit up. And now these things just go straight into the fucking bin. There you go. Bye. Maybe I should actually pick out the things I could still use. Okay, that's dirty. Yeah, the screw's the only thing I can still use. Goodbye.